Okay, we're good if we want to get started. Welcome, everyone. I think I'll hand it over to Kurt to start. This is the, for posterity, this is the Boston HPC and GPU Meetup group, now virtual, perhaps for quite a while yet. We'll see. But it's nice to see people.
That's right. And for those of you that have come to this before, we usually try to do a roundup of the conferences that happen in November. We have quite a few of the industry as well as the scientific academic conferences that happen in November. So we try to catch them all up into one big roundup for people who didn't attend. And that's actually quite a large crowd of us this year. Elliot was virtual. I was virtual. Professor Cayley was virtual. However, Doug was there. Doug Smith was there. So maybe we'll chat him up at the end and he could tell us if there was something unique that happened in St. Louis. I don't think he went to GTC though. Did you go to GTC, Elliot? Or were you virtual for that too?
GTC was virtual with no hybrid option.
Oh, is that right?
So I was there, but it was virtual. Yeah.
Okay. Well, I think we'll start up. The students have, the undergrads from Boston University have to go do some work tonight. So I think we'll have them tell us about their experiences with the student cluster contest. And then I have some non-industry related, actually they're industry related topics, but they won't overlap with Elliot's. And then after that, we can get some feedback from Doug, who is not only an Indy SCC judge, but like I say, he was at the conference. He can give us some Johnny on the spot updates. And that'll still leave us some time. Maybe Professor Cayley can tell us what's new in his world. And if there's any other speakers, that would be great. So let me throw it over to Ben and the Boston University Student Cluster Contest team.
Oh yeah, thanks, Kurt. Hey everyone, it's great to be here. I guess a quick little introduction if you haven't met any of us before. So we are half of the Massachusetts Green Team, and we competed at SC21 a couple of weeks ago. So we're going to be going over a little bit about the student cluster competition itself, what kind of went down during those 48 hours, and a little bit about our experience at the competition. So let me start sharing my screen. And let's get into this update. So for this year, we had less teams than usual. And this is probably just due to the virtual nature of the competition. Originally, it was supposed to be a little bit of a hybrid competition. So we had a lot of US teams that were supposed to come in person, and then international teams that would be competing remotely. However, about a month or so before the competition started, it got moved to being completely virtual. So we competed in this room that we're in for those 48 hours. So some of the teams that were in attendance are us. So we're that third bullet point: Boston University, Boston College, UMass Lowell, as well as like Georgia Tech. There was Tsinghua and Jinan. They were the winners from the other student cluster competitions that occurred this year.
Yeah, so this year there were two cloud providers, for the teams to use. Like usual, we had Azure, where we were given a training budget, a competition budget, and we were able to deploy our own, clusters. Although there was shared SKU availability, and Oracle was a bit different. Everyone was basically given a copy of the same system to use, in the 1 week of training. And the option to use like CPU and GPU on the Oracle cloud. For the applications, on Azure, we had benchmarking, Quantum Espresso, and the mystery application. And for Oracle, we had the reproducibility challenge and cardioid. There's lots of praise for Oracle's system, although they both do have drawbacks. So the application I was working on was cardioid. For the competition, basically the challenge they gave us was, so the cardioid, the heart simulator, they basically gave us a conversion study to do, where essentially we had to reproduce like the results of a simulation from like a paper, where they gave us like 3 different models to choose from and like different, simulation granularity, like resolution and time, resolution. And basically we're trying to see how small of a resolution or how high of a resolution we need, to get so that the results converge to like a certain value. And to do this, we had the option, between using the CPU and the GPU version. On Oracle, I think a lot of teams were able to get the CPU one, but less were able to, figure out the GPU version. So I guess that was one of the challenges.
Yeah. So for the other applications, we have Quantum Espresso. So QE is a simulator for molecular dynamics. And for this competition, we're given some data set to run on the benchmark, and you're judged on based on different criteria depending on the task. For the first 2 tasks, the rubric told us that we only had to finish it using the least amount of money. So we decided to just run it on like a epic CPU SKU to get the job done. And I think we did fairly well on those. And for the last 2 tasks, they were more computationally expensive. So we had to use the A100 GPU node to run the code. And those were taking a very long time to run them. And for this year's mystery applications, we have Cosmic Tagger. So this challenge was based around training a neural network to perform pixel separations in cosmic backgrounds. Personally, I'm not too well versed in neutrino physics, but I was able to navigate through these tasks with some backgrounds in deep learning. And basically for these applications, you're given some data sets, and you have to train a model that outperforms the other team, as well as the author, which I thought is a very interesting concept that they introduced this year. I like that they're trying to encourage us to sort of improve on the methods that these scientists already came up with for their applications.
Yeah, and then our last application was the reproducibility challenge, which is a recurring challenge that occurs every cluster competition. The point of this challenge is you want to reproduce the results from a scientific paper that was submitted to the conference the year before. So for this year, they had a paper about Bayesian learning through Markov blanket discovery. And my task was given these data sets within the time constraint of the competition. I was supposed to use the Oracle cluster to run their code and perform weak scaling and strong scaling experiments with relation to core counts. So I actually wanted to show a bit about the paper that I wrote. Yeah, so my submission for the actual application was an entire paper. So this included like understanding of the actual code base, understanding of the science behind the paper. And after I had run my experiments, I compiled some different numbers to showcase, see if I can get this a little bigger, to showcase runtime based on different core counts for the 2 data sets that were given to me. I also did some stuff on communication overhead with MPI, as well as how different parallel algorithms affect the runtime of the code. So every year, there's usually some type of curveball that occurs at the student cluster competition. Most times when it's in person, this is a blackout. Last year, they actually gave us more money, which was interesting. This year, we were all wondering what the curveball was going to be, and we figured it out. It was cardioid. Running cardioid on the GPU ended up being the curveball. Because there's a lot of setup problems that were occurring. All of the teams, or I should say many of the teams, actually tried to work together to get it working. And we actually talked to we talked to the application owner, and they actually said that it took them 3 days to get it working on the GPU. And this is the guy who wrote the code. So for our involvement within the competition, we were the Massachusetts Green Team. So we spun out of 3 colleges in the Boston area. So the 3 of us plus 1 other were from BU. Another member was from Boston College, and yet another member was from UMass Lowell. So we kind of struck a partnership for this year's competition.
So for some highlights, we were the first out of all the US teams for the HPCG benchmark with 7.38 teraflops. That's pretty exciting. And we were third overall in benchmarking. And some improvements this year over last year is that our HPCG score was 14 times our score from last year. Our IO 500 increased by 20 times. And for the first time, we actually submitted all our applications by the end.
Okay, yeah. So let's talk about the strategy that we employ for this competition, which turned out to be quite successful. So prior to the competition, I was doing some experiments on Azure Cloud to prepare for the competition. And I noticed that when I tried to deploy the A100 GPU SKUs, it just gets stuck. And at first, I thought that maybe there's some issues coming from Microsoft. And this happened a couple of times, but usually it was during peak hours, like before midnight. So I suspected that they're maybe because we're sharing their resources with the other team. So perhaps like one of the other team was using the GPU at the same time. That's why we couldn't get it. So I confirmed this with Andy Howard, who was in charge of the Azure HPC team. And he said that the quotas indeed share amongst all the teams. And there are only 8 VMs. Each one has 8 A100s. So there are 64 A100s in total. And based on last year's experience, most of the teams, they do their benchmarking or intensive workloads towards the end of the competition once they finish all the applications. But if everyone's trying to get the VMs, nobody's going to be able to get that full 64 A100 clusters. So to verify this, we actually looked through all the posters from each teams because everyone was pretty open about how they want to schedule their workloads. And it did seem like no one was using the GPU at the beginning of the competitions. So the competition starts at 8:30 on which day was it?
It was on Monday.
It was Monday, yeah. Monday at 8:30. And we thought everyone would be distracted by the opening ceremony. And I remember once the clock hit, we just tried to grab as many VMs as possible. And we were able to get about like 5 of them, which gave us 40 A100 GPUs. And we ended up getting a pretty good HPCG score because of this. Unfortunately, we still wanted to conserve the budgets, so we had to let the GPU go. And on the second day of the competition, some of the team actually figured this out as well. So allegedly, one of the teams was holding 5 of the virtual machines in hostage in deallocated mode, which means that they had controls over it, like nobody can use it. And this ended up screwing some of the other teams over on benchmarking towards the end, which sparked a heated debate in the aftermath meeting. However, we actually lost some points on the applications because of the GPU shortage. But I guess it's also a reflection of real world scenario that you do have to adapt to different kinds of scenario that's thrown at you. And I thought this fight for the A100 GPU was actually made this year's competition a lot more interesting than last year.
Yeah, so let's take a look at the ending results. So overall, Tsinghua won for the 4th year in a row, and the Southern University of Science and Technology won the LINPACK Award. Yeah, they won the LINPACK Award somehow with 0 gigaflops. That's weird. So what actually happened was that because everything was on a Grafana dashboard, the team had actually uploaded their final result of the HPL benchmark right before the deadline. And it seemed that Grafana kind of failed to fetch nearest results. So we saw that 0 number for the HPL benchmark. This ended up getting cleared up after a little while, and it turns out that SUSTech actually got 280 teraflops, beating out all the rest of the teams at the last minute. All right, so finally, I just wanted to end with some of the stuff that I look forward to most during the competition, which are jokes that happen in the Slack channel. And with that, I guess that's the end of our presentation. We're open for any questions that you guys may have. Kurt, if
you're muted.
Thank you. Did they allow you to use V3 instances on Azure?
I don't think we actually got any of those. I asked Andy before if he could get us some of the Milan chips, and it seems like there was there's like some drawback, not drawback. There's some resistance from giving out those SKUs specifically for the competition. So we had to work with the V2 realms.
So my understanding was they replaced the Milan chip with Milan X in place at no additional cost to the consumer. So I don't know if any of our codes were cache centric, but I've heard some crazy speed ups on certain codes on the Milan X. And yeah, maybe we'll find out more about that after Elliot talks. But that's really encouraging. What some of these and they may have the exact same SKU as they originally did with the Azure V3 instances. But I'm going to look into that.
Yeah, that would have been interesting if we had access to those.
Thanks.
Yep.
Can you go a little bit into your build process? Like what compilers and stack did you guys use?
Yeah, absolutely. So for reproducibility, I had a pretty basic stack. So the entire Oracle cluster was we use Slurm as our scheduler. I built my code specifically so I can actually show that I have it on the paper. The great thing about the code base that was given to us for reproducibility was that the authors had actually documented exactly what versions of their compilers and libraries they used. So I followed theirs for the most part. So that was GCC 9.3.1, G-Fortran, same version. I ended up changing their OpenMPI version to 4.1.1 with OpenUCX 1.11.2. And that was just because the Oracle cluster itself needed that for node connectivity. We were using OpenBLAS 0.3.17, Boost 1.70.0. Those were the standard ones that they had on the documentation. Sconce was used to build the executable. And then finally, the code base itself is at this last bullet point. That's the GitHub link for the code base.
Yeah,
You guys want to talk about it?
Yeah, and for the other GPU applications, we're actually able to get the Docker running, so we didn't have to go through the compilation process by ourselves. But for the library, I believe on the Docker, they were using the NVIDIA HPC pack, which contains like the cuBLAS library and all the CUDA toolkits that you would need. And Carmen, is there anything you want to add?
I guess for Cargo, the CPU version, we were able to build using a program called SPAC. But basically, it builds all like the dependent libraries, inside of a virtual environment, basically. Yeah.
How did you find SPAC to be? Did you think about using that for some of the other software?
I think at one point I tried to install OpenMPI using SPAC when I was first doing my testing. That didn't work out too well, so I switched to building it from source.
Yeah, I heard most of the other team were also trying to switch to other building method other than SPAC because it was a little bit difficult to use.
It's just a bad learning curve. My impression is that once you know how to use it, it can be pretty slick.
Yeah. I mean, the fact that it does checkpointing for you, that's
True.
great.
Yeah.
But yeah, just for the competition, I think most people ended up building it from scratch.
Yeah.
Okay, I can move on now if you want. I have a few slides on my particular area of interest. Let me go bring up I have two machines here, so I can present on one, and there we go. So the area of interest that myself and Howie from the go into. All right. Okay, Howie and I, and at least one graduate student from Boston University, are very interested in the end of I/O, and the way we're going to get there is we're going to, for everybody that loves working with CPUs and knows memory models and memcopy and likes that programming paradigm, well, they will never have to use paging or swap or fetch data from disk anymore if we have enough silicon posing as memory. And the way we get there is we compete with the the DDR4 and the DDR5 bus speeds. So if we can get to the bottom right hand corner there, if we can get to 42 or 52 gigabytes per second for a bus speed on some other medium that has the other features we know and love with memory, and gotten rid of the ones we don't, then we're going to be competitive. So the way we get there, for starters, is we adopt the new PCI Express form factors. So PCI Express wasn't moving very quickly for years. It has picked up pace dramatically in the last couple of years. Most of the systems you're buying now in the hyperscaler shops and the data centers, they're already on PCI Express 4. So you can get a lane that'll go 2 gigabytes per second, and you're getting 96 of them in an Intel server or 128 of them in an AMD server. And there's a lot you can do with that many lanes of PCI Express version 4. Now you'll see version 5.0 there. They are moving at an even breaker-neck pace to get that out in the field. You'll start seeing PCI Express 5.0 in shipping systems, certainly in the first half of 2021, but maybe even the first quarter. So one of the things they had at the show was this, and tell me if this looks familiar, Howie, the CXL development machine. Now you're not going to be doing CXL 2.0 on this, in January of 2021. You'll be CXL 1.1 spec. It doesn't have the full memory pooling suite options that you'll get with CXL 2.0, but still, we'll be able to do a lot of interesting CXL 1.1 spec development that we can then port over when the new PCI 5 cards are ready for shipping. Now, so what the implications of this are, and you'll notice, Howie, there's 2 bays of 8 NVMe drives there. So great minds think a lot. We said, okay, if we're going to devote 4 lanes for every NVMe card, let's do 2 bays of 8 drives, and we'll stripe those. So we'll be getting the speed we want out of that bay, and then we'll mirror them. So the systems we put together and tested that were pre-CXL, in fact, they were PCI Express 4. So we weren't going to be able to get all of our speed out of it, but we figured we'd have some development to do, and we did with the development system that Howie and I worked on over the summer. We will probably be able to get that in place, competitive with DDR, certainly DDR4 access speeds, but first quarter of 2021. Now, it's quite likely you'll be getting a system that has DDR5 on it if you're getting a system that has PCI Express 5 on it. So we'll probably have to figure out some more exotic ways to stripe. It's not unusual to find a system with 16 of the NVMe, the half height bays. I've got a slide later on where they've even got a smaller form factor. It uses a lot of these NVMe cards use 4 lanes of whatever PCI Express you can give to it. Here is a bunch of products from a company called Smart Modular Technologies, which we have. It's a distributed company based out of California, but there is an office in Massachusetts. I may chat them up, and I apologize for the quality of these photos. I will put good proper links into the after we close tonight. I'll go back to the website and dig up some proper spec sheets and PDFs for you, because I know some of these products, they just didn't have this on the website at the conference, so they're putting their spec sheets together. But you'll see in the foreground there's a Gen Z. That card edge there is not one of the PCI Express form factors. I think that one's called EDSFF. Let me see if that's the I think it's EDSFF. And this will be a new form factor on the NVMe drives that they'll be shipping next year. You'll be able to get the crazy size on a single drive, 3.2 terabytes, 6.4 terabytes. that wasn't the feature that we were investigating this summer. We're looking to saturate the PCI bus and trying to find out how many drives we can get. So we would stripe a bank of eight 3.2 terabyte drives, and we would get 3.2 terabytes, but really fast. We were using all of the lanes available to us at maximum speed. So these are the new Kioxia drives. You can either buy it with the new form factor, or you can get these shims that you can then plug your traditional as of the last couple of years NVMe drives into them. That's like the mini PCI or the micro PCI form factor. And like I say, I can definitely get spec sheets on Kioxia. They have done a lot of really interesting investigations into oh, come on, I'm trying to advance my slides with my left hand here. Did that advance? No, hold on. Let me just close out this. All right. All right. That one. So this is I think I leapfrogged. Hold on, I'm sorry.
I think you want 7, 6 or 7.
Yeah. All right, let me do 7. Okay, so this was at the Kioxia booth. Kioxia, for those folks who haven't done much business with them lately, they were previously Fujitsu SSD product division. Fujitsu, right? Yeah. So this right here, they populated this with those drives that are there in the back. So you can run your NVMe over Fabric. What they envision and what a lot of these CXL developers are looking at here is in order to get these crazy memory access, if you need 20 or 30 or 40 terabytes of RAM equivalent for your code, or you could run your code strictly multiprocessor rather than MPI or something if you had this kind of memory access. So they would do either an NVMe over Fabric cluster or data center, or what MIT is investigating is MIT sold off a lot of their Net 18 IPv4 address space to Facebook. Some of my old websites are out there on Facebook somewhere now, and you type in the old IP address and it comes up as mostly a blank screen. But what MIT would like to do on one of their experiments is, now that we're addressing internally on Net 10, and hardware addressing is how they're talking to machines internally at MIT, they think they can also do a sort of a 128-bit memory addressing scheme, where if your particular machine was the definitive source of RISC-V memory addressing, you could access that instead of using an IP protocol, using a memory protocol. Now, this wouldn't, because it's remote, it's not going to benefit you with the kind of bandwidths we're talking about on an individual server or within a rack, but the concept's the same. You'll now be able to use memory addressing schemes rather than client server addressing. So PlyOps makes boards for Inspur. So this is either a 16 or a 24 NVMe RAID system for Inspur. Now, the only thing they did different, Howie and I used Linux software RAID. So they've got at the top there. Let me see if I can get down to that card. They have hardware RAID. So those cards on top are you can throw them into your slots. You can probably control the 96 PCI lanes with one card. So then you can double and triple up cards and then just run this as a JBOF, just a box of Fabric. And here's a JBOG. So I know Elliot has some experience with some of these systems that came out of one-stop systems. This is I think I have a better, no, that's the best photo I have. you can see a place where you can plug in PCI Express cables to the back. So you talk to this box. This box just daisy chains off of your PCI Express bus. For those of you that know and love the microwave octoputer with that single root complex chip, this has like 3 of those. This has like Broadcom root complexes. So you can put a couple of dozen GPUs on a single PCI Express bus, which might make sense if you've got PCI Express 5, if you've got 128 lanes, and if all you care about is GPU processing, because this will eat up all those lanes and then some. Yeah, so there's a shot. There's the one-stop system box. You can see those big honking cables that they took. They took my monster cables off of my speakers and made these PCI Express shunt cables over them. So you're not signaling from one NIC to another. That is a PCI Express cable. And Netlist is partnering with them to make the NVMe drive. So this is what they demoed, was a JBOF. There was probably it says 16 terabytes there. That's probably right. I think they have 60 terabytes per maybe per row. So maybe they had 32 terabytes in here. All right, now the last bit, if Elizabeth Leak joins us, she can tell us about composable computing. Giga.io had a composable computing webinar, a little breakout group there, and I missed most of it. I think Elliot might have seen it at the Beowulf Bash. I went to a different subgroup, but I'll see if I can dig up some of this. This I can definitely get the slides on. They were supposed to post the slides to the Beowulf Bash site and did not, so I will get that. I have some things. We took some pictures. John Schalf and Karen Bergman, who are going to be the general chairs at ISC, they talked a lot on the composable computing and disaggregating. If we're going to be able to access everything across a PCI Express 5.0 bus, where you've got a ton of RAM on a host adapter, say it's a GPU with a lot of RAM, and you're short RAM on your CPUs. Well, CXL 2.0 will let you be able to pool that memory. And it works the other way as well. If you don't have a whole lot of RAM on your accelerator, you can use some system RAM. It'll be very interesting to see how well that works performance-wise. I know we'll be able to do it, and it's going to be at near DDR5 speeds. It's just going to be interesting to see how well. So I'm going to see if I can get one of those CXL dev kits and see how well that's going to work in practice. And it's just jaw-dropping to me that some of these products are going to be out on the street January, February, or March, and almost everything will be out. Certainly CXL 1.1 will be ready in retail and commodity devices by next supercomputing conference. Now, I don't have anything else, but I know they did announce the new Jetson. The student team and I always like getting the Jetson when it comes out. And this year, and it usually lags about a generation behind NVIDIA's enterprise line. So we'll this is announced but not shipping. So, and maybe Barton can bring us up to date on the status of this at the end. But those are all my slides, and I apologize for the scatterbrained nature of it. I'm just so psyched on the directions that the NVMe drives they're revving so quickly. They're getting better, faster, and cheaper. And the one feature set that I'm very interested in optimizing on is being able to just increase the speed of them up to the bandwidth that I have available on my copious, 16 slot buses now. It's going to be very encouraging to see if we can have a dedicated system, a single server, a 5U server loaded with NVMe drives, and maybe that's our only storage. And at some point, it's not going to be storage; it's going to be non-volatile memory, because the memory you're working on will either be you'll either be in the application, or you'll be in power level 3 or something. It's not going to move. You'll save a ton of joules not by moving it in and out of RAM. That will be very, very interesting to see what kind of paradigm, or what kind of programming paradigms will come out of that. So I'll pass it off to anyone who has any questions.
I'd definitely like to interrogate it a little bit because I'm still, wrapping my head around some of this. I don't know if you used the word composable. Maybe you did, but that's what they're calling this stuff, right? It's most of the composable that I've seen is PCIe 4, PCI 5. Is that right in your experience?
Yeah, and CXL needs PCI 5. It sits on top of it, so that's going to be a while before we see.
And a lot of what I've seen with that is it gives you more flexibility for some increase in price. Do you know what the some increase in price is? Do we pay 10% more for our HPC cluster if it's composable? I feel like I should have that number, and I'm embarrassed that I don't.
So the way I'm rationalizing it is they're abstracting out between the host and the device. So you won't have CPU has to be host and your accelerator card has to be the device. That's not necessary anymore. So I'm going to save a ton of money by not having to buy RAM, because I'm already getting GDDR5 or 6 on my GPU, and I'm getting tons of it. So if I can use that as system RAM, then I'm certainly not putting it on a legacy DDR4 bus. That's how I'm going to rationalize the price difference. I got to figure CXL5 ready, probably a 10% cost margin, but maybe more. Only so Marvell is the big chip company in that space right now, and I know there's a lot of people that are CXL consortium members, but it's an Intel initiative. CXL is so they'll be the 800-pound gorilla there too.
I see Ted has his hand up.
Yeah, I have two questions. One is assuming that the PCIe 5 and CXL can approach the speeds of DDR5. Do you have any feeling on the latency is the first question.
Yes.
And
go ahead.
Well, my second question is, how do you do conflicts? Is it going to be something like CSMA CD, or if you have two resources, two things trying to get at one thing, for example? So those are the two questions. Conflict resolution and latency.
So I think what is going to happen, and we've already seen this with the IBM, the modern IBM Z series, is you'll have companies like AMD that are just going to keep putting solder bump cards on top of their processors, and you'll be getting dozens of gigabytes of level 3 cache. Now, when you've got that as your processor, what we'll be doing with these JBOFs is making a level 4 cache. So you speculate everything out, and then you would have to go to disk a lot less often. But more importantly, you'll have to go to RAM a lot less often. So it can take up to 300 clock cycles to go in and out of RAM. And you won't have that problem if you've got a really aggressive cache management system, which apparently one of the things I'm going to post to the website is the IBM Z series RAM scheme. They mix and match their level 2 and level 3 caches. They're not only shared between processors, but they can do both functions. So I'm going to post that.
Did that answer my latency question in there someplace?
Yeah. So we're getting hammered at apples to apples. RAM still kills us on latency. However,
Okay.
we're going to circumvent it by not by just caching everything.
Okay, fine. So architecturally, get around it, basically, avoid it.
Yeah. In fact, I would imagine DDR5 we're already being beaten on by a factor of 10 on latency with DDR4. It might even be worse with DDR5. PCIe 5 to DDR5 might even be worse. But like I say, I think we're going to everything that we can cache into level 4. I think we will, because we're buying these drives not because they're 6.4 terabytes, but because more drives, faster access is better built.
So is it fair to say, in other words, that there's still going to be many tiers of memory and storage? They're all getting faster. I mean, or is this adding a new tier or replacing an existing tier?
Well, I think the physical drives will perform as both L4 caches as well as fixed disk. So the data will be there. It's whether we're accessing it through a cache scheme or we're reading it or an IO scheme.
Do you have any idea again on the conflict, conflict resolution schemes? In other words, two things trying to achieve, reach one piece of memory, for example.
So my understanding was CXL does non-blocking access.
Okay.
And and I'll have to dig into so that may allow you to do simultaneous reads, but
yeah, if you're doing non-blocking, then it's a non-issue.
Okay,
Yeah.
I think that's my understanding, and I can get. I have your address, Ted. I did. Howie and I did a paper at HPEC, and I'll send you that because CXL was just basically being workshopped at the time. So I'll see if they've nailed that one down.
Okay, thank you.
All right, you want to go, Elliot, or should we have?
Yeah.
We can have Doug, but Doug may want to wait.
Oh yeah, Doug. I can go. I can go later.
No,
That's fine.
No, go ahead, Elliot. I can
All
go
right.
last.
All right. All right. If you want to turn yours off, Kurt, I'll take over. I've got a different kind of HPC. I got my high performance K9 here. You can see it. Hopefully it doesn't distract us too much.
It's very compact. Very compact.
That's
design.
right. It's a high density HPC. All right, here we go. Okay. Yeah, this was very. This is I don't know. There's been some interesting times. As Kurt said, I didn't go to GTC. That was virtual. I didn't go to SC in person, even though that was an option for some. So I am certain that I missed things, and a lot of this is based more on press coverage than it is on maybe what was hot at the show, so to speak. But I think we'll have a few ties with what Kurt was talking about as well. And maybe a little bit of provocative conversation starting too, hopefully. I'm going to start with supply chains, and I might disagree with what Kurt said earlier that you're going to see gear in January and February, because for a lot of gear, at least that I work with, if you didn't order it this summer, you won't be seeing it in January or February. There's quite a bit of HPC equipment that has 3, 4, 5, 6 month lead times right now. So it is a new world. Some of the big suppliers are simplifying their SKUs, not building as many different SKUs to try and fulfill something. So sometimes you're getting something similar to what you ordered, but not exactly what you ordered, so to speak. So it's a challenge, and I know leaders of all the the leading HPC chip makers have spoken to this, that they're working on resolutions, but those resolutions may be a year or two in coming. So yeah, it's tough out there right now to get some of this HPC gear. I'm going kind of in chronological order here, covering some of the news over the last couple months, weeks. So AMD did kind of an accelerated data center day, where they talked about what they've got coming, and this is one that Kurt alluded to, Milan X. So it's kind of a +1 on their current generation server CPUs. They put a huge layer of L3 cache on top of the chip. And this is what I was kind of talking about. These are we getting more tiers of memory, or the tiers just each getting faster? So this is L3 cache like you've never seen before. Hundreds of megabytes of L3 cache, versus a year ago you'd be seeing 30 megabytes, 50 megabytes. AMD has had a bit of an advantage there for a while, but this is just crazy. And you can see there at the bottom that they're talking about a 50% speed up for some of the technical computing. which is a lot of the engineering simulation codes that they've seen a lot of benefits on. So this will be ostensibly shipping quite soon, and into any of the existing types of servers that you use for AMD EPYC. Though, same caveat on the supply chain lead times. If you don't have orders in, you will be waiting a while. And then they also talked about their MI200 GPUs. These are the GPUs that are going into some of the US's exascale systems. And you can see there that they're claiming almost a 5x performance improvement over their competition for HPC, and not quite as much but still an advantage on AI. So this is an impressive beast. One of the members of this group, VJ, does a really good presentation from time to time, and I'm excited to see what he says on some of these head-to-heads of the different architectures. Let me jump. So this is AMD's comparison, right? So take that with a grain of salt, but AMD's comparison of the NVIDIA A100 GPU versus AMD's MI200 GPU, and right, and they're saying 2x to 5x performance differences. My grain of salt on this is that the MI200 is 2 dies on one chip, right? So I do wonder whether the more fair comparison would be 2 A100 dies together versus 1 MI200, but that might not be a fair comparison in other ways. So AMD has showing very impressive performance here, at least on the theoreticals. It's going to be interesting to see what folks see in practice. I don't know, Dave, if you've got a comment.
Yeah, this is sort of what we're we're seeing those kinds of numbers on the MI100, not as big a difference, but it's for particularly for single and upper position, they're hard to beat.
And I think to some extent it was a design decision, right? NVIDIA has built a lot of features.
Philosophy decision, a marketing decision to go. NVIDIA's your AI engine with tensor cores, and AMD is your FP3264 GPU. So go pick your poison.
Yeah. There's another thing that I don't think speaks as much to the HPC crowd. It does in a few instances, but the A100 GPUs can be split into separate hardware instances, which is really useful for virtualization and some of those things. Less so for crunch your biggest HPC jobs. But again, a design decision in the A100 that might explain why there aren't quite as many transistors going to big flops numbers.
So there was a question about whether the matrix numbers versus the vector numbers, isn't that sort of like the tensor number?
That is my understanding, yes. Let's see that question.
From Mark.
Okay, all right. So and I am not a linear algebra whiz by any means. So yes, if we look at the top row, the 9.7 teraflops versus the 47.9 teraflops, that is for that is an FMA op, and then the matrix operations for the AMD are equivalent to the tensor core operations on an NVIDIA. So it's got to be packed right to get those numbers. And if you look back a few generations, it was that you could do these packed matrix operations at lower precision. I think originally it came out from NVIDIA with FP16, and then there's been some flip-flopping back and forth between the various GPUs.
Right, but this looks like it's doing it at full FP64 and
yes,
FP32,
correct.
which is pretty incredible.
It is, and I don't know how many applications leverage that now. I've seen discussion and developers talking about it, but I don't know how many of the big HPC codes are currently throwing matrices of FP64 at any of these GPUs. But it's certainly going to be coming down the road. All right, I won't belabor this too much. I think this is the only product. I know Kurt was talking about the Sapphire Rapids that's coming from Intel. This is the only product that I really am talking about that isn't coming soon. Most particularly because you'll see CXL on there. So Kurt mentioned that Intel's running the show with CXL, but AMD has jumped on board too. And I don't know exactly how big of a wave that is, but it might be a change from what some people expected. So there's going to be a lot of vendors that are going to be able to, ideally, right, going to be able to talk to each other via CXL. And you'll see at the bottom there, they're saying on track for 2022. I'm sure someone's going to get them in 2022, but most of us aren't going to see them until late 2022 or 2023, probably. It's impressive stuff.
So you can get some CXL functionality with the first rev that they're coming out with that's going to be of some value to HPC is 1.1. And I think we'll certainly see dev kits in the first quarter. Now shipping products, okay, so that's not very encouraging. If PCI Express is held up. yeah, we can't use CXL without PCIe 5, so.
Well, and I think all of the vendors have professed their intent for PCIe 5, right? So who gets their servers out the door first, I'm not sure, but it is coming. And I don't know if it's maybe at this point supply chains more than anything else that will delay it, but yeah. I'll move on. We can circle back to this because it was only the first day of a couple of weeks ago. So NVIDIA ran their fall GTC. It was all virtual, and I know I've said it again, and I'll keep saying it. They do put on a really good show. I think it's easy for them because they're very focused. It's not like SC where they have to herd 1,000 different cats of vendors and presenters and everything. It's their show the whole time. But it's good live and it's good later. So there's a lot of resources there that you can go and poke through after the fact. And increasingly, there's a lot of presentations from their customers. So you'll find things that are interesting, even if you're not, looking to learn about the latest GPU. You want to learn about the latest methods for GPU programming or something like that. You should be able to find something, or AI, right? There's tons and tons of AI. But overall, I would say GTC was about solutions, broader conversations. It was not about, hey, here's the new hardware, or here's CUDA, the next version of CUDA. It's wide ranging if you want to look through some of the things that they're talking about. But a lot of it is AI, really deep learning, successes across a variety of different industries. One of the things you'll see there is digital twins, which is probably not a new thing for a lot of folks in HPC, right? We've been doing engineering simulation of products before they are produced for a long time, but maybe you'd say that's increasing in fidelity. So you'll see, someone's designing the next phone, someone's designing the next car. There is a quote unquote digital twin of that, a fully digitally created version of that product before it exists to, sometimes just to look at it. Is it pretty? Is the design aesthetically pleasing? But also very much from an engineering perspective, what is the electromagnetic properties of it? Interference, optimizing antennas, doing crash simulations, or whoops, I dropped my phone simulations. Simulations on how the touch screens operate, all that kind of stuff is increasing in fidelity, and that kind of leads to Omniverse, which is NVIDIA's augmented reality, virtual reality play, and if you see here on the left, they're talking about, basically the world as it exists today is on the left. You've got the physical world interacting with the internet, mostly HTML, web traffic, that kind of thing. And they're tying that into their Omniverse, which is, it might feel very hand wavy for those of you who saw the Facebook Meta announcements. What is this? This is virtual reality that's going to destroy democracy or something. But Omniverse is more practical and focused, and already has useful use cases. So you can, if you want, you can go on, you can find some demos where they're showing multiple architects or multiple engineers working on the same project. An engineer or an architect will change the model in some way, and that will show up live to the others working on the same project. Not necessarily even in VR, but just, your traditional AutoCAD type tasks, being able to collaborate live on that. And I think that may have some of the same benefits that we see elsewhere. We see in code development, when you can collaborate more easily, you iterate faster, right? You're able to develop more rapidly. So that's the intent from kind of an engineering perspective. I very much see the application there. I think we'll have to see on some of these other things. I personally am not as close to the media and entertainment space, but this USD that they show on the right-hand side, that's the universal scene descriptor that allows all these different graphics and engineering apps to talk to each other and share kind of the ground truth of what the models look like, what the virtual world looks like. So it's interesting, and it's a lot less pie in the sky than what Facebook is doing. There's very real world applications, and it's already functioning for customers. So that'll be interesting, I think, for a lot of the graphics type folks, a lot of the engineering folks, and we'll see where it kind of goes from there. And then jumping on to SC20, which was in St. Louis. I think they had maybe like a quarter of the people they normally do. And unfortunately, a lot of the big vendors stepped out, and then that was kind of it. So, definitely lower attendance, but some people are saying they had great meetings for the people who were there. They got to have some very interesting conversations. One of the big things that is going on right now is it the end for the top 500 list? So the top 500 list has been, I don't know what you want to call it, an international ego contest more than anything else by some people's interpretations. It was started as a way to measure progress, if you will, for high performance computing. But the detractors would say what it ended up becoming was building bigger and bigger hardware just to hit a number, even if the system wasn't going to do anything useful. There are advocates and detractors always, but what has happened is that China has deployed more than one exascale system over an exaflop, but they did not submit it to the list. So now there's this fragmented landscape where we have a list of the biggest supercomputers, but it doesn't actually include the largest supercomputers. And what do we do with that? Is it still useful? Is this productive? And of course, the people who have been detractors all along are saying, you got to throw it away. We're building systems that aren't any good to run actual research code. They're just good to get a big number. It's time to move to something real. So I don't think the story's actually over yet, but it'll be interesting to see what comes next. And some of the originators of the top 500 list, which the application for that is high performance LinPack. There are other benchmarks out there already, right? That other large sites are running. So there are other options, and we could, the industry could move in a different direction, but that may continue to take some time. There's a top 500, there's a green 500, which is the kind of most energy efficient computing. And perhaps that could be a good way to go, but again, it's going to be dependent on a benchmark that's meaningful. The folks that designed the Fugaku supercomputer had a lot of good things to say about that. They've shown some very impressive efficiency levels that beat out a lot of the existing HPC systems. All right, so this was one of those great conversations that just apparently happened incidentally. I don't know if you folks saw this. So Serve the Home was able to have a sit-down conversation with one of Intel's leaders, Raja, and there was kind of a very bold statement that Intel had made, that they're gonna show a 1000x increase in 5 years, right? So we're fielding an exascale system now-ish. They want to see a zettascale system in 5 years, which is a bold claim. So this article, and we'll post the links after. I'll post my slides. This article goes into how Intel is arguing that they're going to get there. And for the sake of comparison, I put some of NVIDIA's recent postings of performance on the left-hand side. So it might be fair to say that there's more than one vendor that, at least from a marketing perspective, is saying that they're going to see 1000x increases in 5 years. And NVIDIA might be able to claim it on some of their deep learning training, but it was not just we made the hardware faster. It was very much software improvements combined with hardware improvements, a lot of optimization. It really feels like a stretch to say we're going to see 1000x. I looked at some of the historicals for my my own work at my day job, and I my customers haven't seen anywhere near that speed up in general. Yes, for some of the very highly tuned deep learning training, there have been some impressive speed ups, but for your average HPC code, I see customers getting a 2x, 3x, 5x increase over this kind of a time span. It's not multiple orders of magnitude on top of that. So fun if we get there, but my goodness, it is an ambitious goal. And then composable compute, which Art already covered pretty well. This is my take on it. I think it's very interesting. Do we have a question? Oh, okay. So the composable compute is very interesting. I know that it's had a lot of interest. There's been some big wins. I know there's some university customers deploying systems like this. There were some large government wins that were awarded to some composable compute vendors, being able to define your node when you submit the job. I want this amount of memory, this amount of GPUs. I think I have some of the questions that Ted had, right? Like, what is the latency? I know some folks have been saying it's not really going to get there until we have the PCI Express going across photonics instead of a copper cable between these systems. It's got to be fiber, and then maybe the latency then will come into line. And I also question, as I'd questioned Kurt earlier, if all of the tiers are increasing in performance, if I now have hundreds of megabytes to gigabytes of very high speed stacked memory on my chips, then DRAM and storage on the fabric are still pretty far away, relatively speaking, from a latency and throughput perspective. So I'm interested to see where this one goes. My last one is probably we probably really need to wait for VJ or Kurt or someone to speak up here. I mean, I'm starting to see these conversations from my end, but I haven't been able to follow them as closely. So there was apparently a very good session during SC for RISC-V and ARM. They are very viable, right? And I know more so from the ARM perspective than RISC-V, but ARM performance is good. The software is ready for ARM. It's easy to run your codes on ARM for the most part if you're an HPC person. But what I question is there enough goodness to force a transition? Am I getting twice the performance for half the price or something if I move to one of these other architectures? And for your average HPC user, I'm not sure that it's there yet, and I'm curious if people have pushback for me there, because I haven't seen it and I would like to see it. It seems like ARM is a little bit, maybe it's a little bit more power efficient, or it's got a little bit more performance. So will that cause the user to transition? I think maybe there will be some things coming down the pike if we see some amazing synergy between one of these open architectures and some other HPC accelerator. Then maybe really there is some transformative capability that we don't see today.
Well, I think you know the answer, right?
Yeah.
Think about the 80s and the 90s. We had DEC, HP, IBM, Intel, MIPS, Sun, all slinging silicon, and the biggest difference between any of these vastly different architectures was 10%.
Mm-hmm, mm-hmm.
There is no way that ARM is going to be 2x faster. It's the same principle, right? A deep pipeline slinging instructions. If you look at the investments in Tachyon and Asanium, that's a different process, right? That's the Doug Berger approach. Have a sea of ALUs and have a compiler that takes the graph and maps it onto an array of ALUs. That approach may have a 10x over a standard ISA machine, but ARM and RISC-V aren't going to compete or not going to deliver anything significantly over an x86.
And so maybe it's not so much about the performance, it's about the freedom, the flexibility.
Yeah, I think RISC-V is that, I think, well, let me not put words in anybody's mouth. RISC-V to me is that freedom. And the Europeans certainly feel, what's the word, emboldened by the prospect that they do not have to ask permission from an Intel or an AMD or an IBM and simply can do it. Now, the 10 billion that they've allocated to me is going to be an interesting project to track because they never have built an HPC stack top to bottom, right? So it would be unheard of for a whole continent to go from zero to the forefront without having a skilled labor force that has done silicon, that has done systems, that has done software, that has done computational science, all at the same time, right? But hey, I am willing to be convinced. I am rooting for him. I am talking to all of the RISC-V, the CODA-SIP, the Semi-Dynamics, you name it, right, of Europe. There is energy, but it ain't gonna be significantly better than an x86.
Well, I'm not close enough to the situation in China. Is that precisely what China has managed? Are they fully homegrown now?
Well, they took a MIPS, right? They took the MIPS machine and now are sort of expanding that. But that's the same. MIPS is not bad. It's just that you're still in the same concept of a sequential stored program machine that uses an ISA, and you're not gonna change the world with that. Yeah, to me, it's going to be super interesting to see what Tachyon and Asanium can pull out, because they basically are betting on SMT solvers, right? They're basically saying, hey, satisfiability solvers are going to be good enough that they can solve this problem for your spec benchmarks. That is going to be in my mind, that's the big question in my mind. Can they deliver that? Because if they can do that, then there is a fighting chance that we have a new computing paradigm.
Okay. Do you have links you could post in the chat for those? I actually haven't heard of those.
Asanium and Tachyon?
Yeah.
Sure.
Yeah.
Let me dig it up for you.
Also, the RISC-V Summit is in about a week, Elliot. So there'll be a bunch of announcements there.
Okay.
Here comes the first one. Chat. So Asanium is run by Peter Foley. He started Wave Computing. Now, Wave was a massive implosion, but that's where they started to try to do an asynchronous asynchronous sea of ALUs for which they needed that satisfiability compiler, and they never got it to work. But Asanium is the follow through, and Tachyon was one of the guys that was part of that wave computing team, and he also raised some money to try to build that. Tachyon.
Thank you.
Yeah, I bet more on Asanium, Peter Foley, than Tachyon, Rado. I know both guys, and Peter is just a more practical thinker. They have a hill to climb, but that to me is the difference. You can't change the world doing the same thing, and all I say is just take a look at the billions of investments that were made by HP, IBM, Sun, Intel, and they all ended up in the same place, silicon wise. Right.
Well, this is my last slide, so I can hand the torch.
This is awesome. Very good. Thanks, Elliot.
Yeah. Am I handing it over to Doug now?
Yeah, I think so. We were going to have a grad student from BU, but I don't see him, so I think it's Doug's turn.
Well, hopefully I'll provide some, no slides, maybe the dessert to, right. First thing is the Indy SCC. So for those of you that, I don't know how familiar folks are with the Indy SCC, but this was a development effort that was put forth for teams that applied to the traditional SCC, but whose proposals were not quite up to competition standard. The judges felt like these teams needed a little bit more development. So they were offered this Indy SCC competition. It's completely virtual, done in the cloud, using the Chameleon cloud. They had 5 teams. And I'm sorry, I apologize for any background noise. I'm outside. This is actually my commute, my 2-hour commute. So
you sound okay.
So 5 teams, Texas A&M, a team from China, Australia, Switzerland, and there was one other in there. Of course, the team from China won. They did an outstanding job. Most of the teams, they were offered ARM nodes, 2 ARM nodes, as well as traditional AMD Intel nodes. No one used the ARM nodes, which I thought was interesting. The applications were a variety of applications. The mystery application was an application called DeVito, which I am not familiar with. The other applications were John the Ripper, and then of course the benchmarks, HPCG and LinPack, and then they had a quantum chemistry model in there. Most of the teams were they made up their deficiencies. They learned a lot. I think the main criticism was they would have all much rather been working on real hardware as opposed to cloud. But they liked the idea that they could all stay at home. So the conference overall, and running a hybrid competition, or a competition that's, well, I'll speak to the conference a little bit. A hybrid conference is a bit more challenging in that in person, there are a lot of technical difficulties and getting remote speakers, presentations queued up, things like that. Typical that you would see in any remote presentation situation. A hybrid model, most people felt like There are valuable characteristics to a virtual conference, right? You can attend from home in your pajamas and get up and get a snack when you want. There are positive attributes to an in-person conference, hallway conversations, meetings, things like that. Adding both of them together takes away from both of them. So adding a virtual aspect comes at the cost of some of the in-person attendees, in that you have sessions where the speaker is remote, speaking to a room of people that are there, and you run into technical issues. And the flip side is true as well. I heard a lot of people say that the hub concept worked pretty well, but they ran into various technical glitches on the hub system as well. So the numbers from committees that I interacted with were, if you're unfamiliar with a traditional SC, you're looking at 12 to 15,000 registered attendees in person. This year, everybody seemed to be throwing around a 6,000 number for total registrants, and roughly half of that in person. So it's a much different conference experience with only 3,000 people in attendance locally. Like was mentioned earlier, the presentations and hallway conversations, everybody got a lot of value out of them. Obviously, with only 3,000 attendees, you can have a much more intimate face-to-face than when you have 15,000 people. The show floor was a ghost town. Really, the only major vendors that showed for the vendor exhibit: HP, IBM, Red Hat, SUSE, right? No NVIDIA, no Cray, no Dell, no Intel. And the interesting thing was the AMD was there with what I sort of call the biggest waste of money ever, because they had a booth but didn't have anything in it.
Oh dear.
So whether it very well may have been a supply chain issue. They didn't have product to demo, but it's a hard. I feel like it's a hard marketing exercise when you have marketing people there and no product to point at. Very, very, very thin on anything hard to look at or present. And that was a common theme. Digital twin, which was mentioned earlier, that was a big buzzword that was thrown around everywhere. Digital twinning into ops type applications. So digital twinning into networking and interconnect was an area where there was considerable movement. Next year's in Dallas. The committees are saying they feel like next year we will be back to a more normal conference. Of course, this all happened before the latest round of variants were discovered. So
yeah, I thought I'd be back this year, but that's not how it turned out. Jeez.
Yeah. Overall, the in-person experience was very good. Just much more like an ISC than an SC. Things pretty much wound down at 5-6 o'clock. St. Louis is a great city. However, I think there were, people had a lot of concerns about safety. I didn't personally see that as an issue, but that was a concern amongst multiple people. An interesting thing was everybody's budgets were cut, right, for the committees and the conference and so forth. And that manifested itself. If you're used to going to SCC and you're one of the people that buys an SCC t-shirt or something at the SCC merch, they ran out of a lot of things Monday afternoon. So, and that was, from what I understood, was both budgets being cut for the conference and supply chain issues, right? Most of that stuff is made abroad, and I can say personally, at least at my lab, we ordered new cluster nodes for one of our clusters in August of 2019, and we got those nodes in November of 2019. We just recently ordered nodes for one of our clusters this August and from Dell, and they are projecting April for their delivery.
Yeah.
Wow. And
Ugh.
we were warned that was a soft projection. So like everybody else, we're all waiting for the FedEx guy. Yeah, so like I said, I felt like the conference was really good. My meetings, the presentations were excellent. Just pulling off a hybrid conference is hard, and I think the conference organizers did an outstanding job given the environment they were put in. There are whispers of how long they can go like this, how long they can go with 1/3 of attendance. I don't know how much credit to give those whispers, but last year there were whispers. This year there were more whispers of, how long can the conference go with these reduced attendance and reduced budgets. The ACM representation, Ashley, was very upbeat about the future. I didn't get a chance to talk to Bill Gropp about what he felt from the IEEE side, but yeah, the other, of course, top 500, as was mentioned earlier, is always a soap opera. There's speculation about China. They look at their all of the metadata about their internal supply chains and their internal data center builds, but yet they don't release any numbers. So, that was kind of the buzz coming out of that. One interesting highlight, I don't know how many of you caught Vint Cerf's keynote speech, but Vint always gives a pretty good presentation. The interesting thing about this year's was he mentioned dependence on technology and the ripple effects when the technology fails. He referenced a presentation that he gave in San Diego about dependence on all things that run on electricity, and then evidently later in the day, San Diego suffered a 2.5-day power outage, to which he caught some flack for prophesying. The irony was he spoke a little bit about this digital dependence and on remote connectivity, and then 2 hours later, the hubs or Google Cloud,
right,
the hub system relied on, crashed. So he may not get to speak anywhere ever.
I guess he's right.
Again.
Yeah. I mean,
somebody joked, they were like, gee whiz, Vint, you know how to prove a point. So yeah, that was kind of the conference in a nutshell, the show floor vendors were a lot of vendors that probably wouldn't get as much foot traffic in a normal conference year as they did this year. A lot of companies that I've attended this conference for 25 years, a lot of companies that either they're new or they are, they got a deal on a larger booth because of the reduced attendance and they took advantage of it. A lot of sessions, the cloud continues to make inroads into HPC. Over the past 2 years, the common cloud vendors have all upped their interconnect offerings. Used to be 10 gig Ethernet was about all they'd offer, but now they're beginning to offer OmniPath, InfiniBand, things like that. So that's a continued story under development. So yeah, that's kind of the wrap up. I'm sorry I didn't have slides. I kind of didn't have time to really prepare for this, but I really appreciate the invitation. Hopefully I can come back in the future.
No, that's cool. Thanks. Yeah, no, it's definitely multiple perspectives welcome. I think Kurt and I talk here more than we should probably. So please come back.
We have trouble finding speakers.
No, do you guys usually, I'm sorry, I'm interrupting the natural flow of your meeting, but I was curious, do you guys do this meetup on a monthly basis?
We should, and we don't always have a speaker, as Kurt said. So we would definitely get together monthly-ish if we had people that were, enthused to talk about what they're doing and what they're seeing.
Yeah, it sounded like Kurt, your team from Boston there did really well in the SCC.
Yeah, so this year they were very familiar with the eccentricities of Azure because it was 100% Azure last year. And we thought for the longest time, we had already bought airline tickets that we were going to St. Louis. and then just at the last minute, they said, nope, there was going to be teams that were staying at home on Azure and teams at the competition that were bringing their own hardware. And at the last minute, they decided to make everyone virtual. They did allow some teams to come to St. Louis. There just wasn't any, you didn't see any booths for the competition or anything, did you?
There was a booth for the competition, but they had a few students hanging out in the booth as a place to crash from going around and going to talks. Posters were there, signage was there, but that's about it. Okay. It was, and I think it was really pretty, honestly, I think the SCC representation at SC21 was as good as you could do under the circumstances.
Yep. So we're going to try to do a student cluster contest at PERC 22 Boston. I think Theodore might be involved. Elizabeth Leak will be involved. And I think some of the folks you worked with from Georgia Tech will be involved. So hopefully we can get you to come to town for that.
Yeah, I actually spoke with Elizabeth Leak while she was there. However, we didn't get to meet face to face. I believe she was under the weather and spent a good deal of time in our hotel room, which is kind of sad. To go all the way to a conference and not get to participate at all, that's a bit rough. Yeah, hopefully, I'd love to be involved with that.
Yep. Yeah, you're going to want to come. You know somebody at MIT, right? So yeah, you should come.
Yeah, I think I know a guy.
You know a gal.
Yeah, that too. She's finally in her element, loving life, attending classes. So
this is Doug's daughter. Is she a sophomore?
Yeah, she's a sophomore this year.
Excellent. All these students returning to to college. I had somebody tell me it was like they had their second freshman year because they were away for COVID, and now they're back, and it's quite a time.
Yeah. She, her and a group of incoming physics freshmen all got a house in Medford last year. And so they just all huddled in their house in Medford so as not to be at home for their freshman year. So she'll have an absolutely unique freshman year experience. And so
we had a question come in here on the chat from Alex, curious if anyone has teams doing .NET GPU work, which I haven't heard much, and we lost Dave already. I don't know if he has. Alex, you want to say more about that question?
Yeah, I just heard you were looking for speakers, and I run an open source program office that is generally a little higher up the stack than what you all, what I've heard you all talking about. You're generally all looking very much at the hardware, and I'm looking a few levels up generally, but I don't know that, the CNCF research user group, there are some characters from CERN in there and various universities, and there are some discussions there that might be interesting to this group. That's all about batch processing on top of Kubernetes and those kinds of topics. I don't know.
Definitely Kubernetes. We do a lot of Kubernetes.
Okay.
.NET is not that interesting, but Julia would be.
Well, that's cool. I've just been talking with Julia Computing a bunch. We've just invested in Julia Computing, and I'll probably be sponsoring Julia Computing through my department. So I'll be happy to chat with them. I've got another chat coming up in a week or two. I'll talk to Viral about coming here and having a conversation. What would you be interested in Julia?
Excellent question. So now I'll speak for my own interests, right? We're working on sort of generalizing mixed precision optimization for energy or memory bandwidth. So these are all custom numerics. We have a software stack that has tens of thousands of number systems that people can pull in, but it's all template based. So you need a C++ or a Julia environment to be able to enable your linear algebra to take advantage of this mixed precision optimization piece, right?
Okay.
So it's this whole idea that energy efficiency and memory and networking communication bandwidth efficiency can be had by looking at the numerics of your algorithms and then dialing in the right number system for that stuff. And the application here is really FPGA and software-defined fabrics, because that's where you can actually change the data path, right? So this is where composable disaggregate infrastructure comes into play, FPGAs come into play, concurrency and linear algebra and numerics come into play. And C++ and Julia are sort of the two languages where that is sort of innate in the environment. Your Python is is really difficult to extend with custom number systems. C is not a good place. Java is not a good place. .NET is not a good place. So that's the context.
All right. I'll check in with them and see whether there's they have some time to come and join this. Who should I connect them with here?
Kurt and I are the co-organizers, so you can message us, or I'll post
Kurt,
I'll post my email here too.
Yeah, Elliot usually lines up the industry speakers.
Yeah, if you want to email me there.
Yeah, and
in the chat.
You mentioned Kubernetes. There are a couple of us doing like multi-cluster batch processing schedulers on Kubernetes. I could bring in us.
Dude, love that. Yeah,
Okay,
Kubernetes schedulers would be fantastic.
Great. I mean,
we haven't had a Kubernetes talk here. We really ought to. It's probably been a couple years too long.
Yeah. All right. Well, I'll connect with Kurt, Elliot, and see
Fantastic.
who I can drum up. There's a bunch of people. It's interesting. While you've been talking about the wait times for gear, I actually kind of get excited, perversely, because well, it makes me feel like maybe we'll actually have to focus on the software.
Right.
And all the problems that are going on above the hardware, because
Dude, that's too hard. You know that's too hard.
Yeah.
So long overlooked, right?
Yeah, well, because it's so hard.
Right, just throw more processing
Hardware
power.
in it, yeah, exactly.
Yeah. So anyway, that's me.
Awesome.
Okay, well, thanks everyone. Maybe I'll call it unless anyone has any burning comments left.
Barton, do you have any updates?
He messaged me that he had to drop, but I still
here we go.
see him.
No, can you hear me?
Yeah.
Yes.
Yeah. No, I've been fascinated listening to all these topics. So, I was at SC21, so got a chance to experience it. I actually sent myself this year on my own. So that was my vacation time. But, exposing myself to that is worth it in every regard, and met some new people that I wouldn't have met any other way. So for me, that was certainly worth the investment, and I'm thrilled to see that the Cluster Challenge team did as well as they did. That's great, especially getting all the submissions in this year. So I had asked whether or not there was any possible benefit to have using MIG on those A100s and farm out, some smaller pre-allocated or shared number of MIG instances, and technically, as long as everybody had access, then it's still a level playing field. But that may not have been possible through the virtual machine infrastructure that was made available to those folks.
So I'll look into that. I also had I sent Elliot this question. There was we're trying to figure out some exotic way to do power capping on the GPUs, and we might be able to do that in SMI. Maybe is that right, Elliot? Or
if it's an A100, absolutely. Yeah, any of the data center style GPUs, NVIDIA SMI will give you all kinds of flexibility on power.
Yeah, we're exposing more and more granularity and controls over, in that regard. So even if it's not there at this moment, probably by this time next year, there may be some more specific controls in there.
Okay.
Kubernetes is a great topic. Be happy to get an NVIDIA speaker on that. We do have some scheduling of Kubernetes technology, in either in the works or delivered. The comments on Omniverse were relevant to, trying to map the digital twin. That's going to be our framework for it, as well as Meta could potentially deploy, their runtimes or do development using Omniverse. So one thing that is important to point out is USD is actually a Pixar invention that we and others are standardizing on. So that, along with the uniform material description and ray tracing, is just bringing an incredible level of realism at scale in those frameworks. So no, I was just listening in. If anybody had specific questions about things from NVIDIA, I'm happy to take questions, or we can look at reconvening and get a list of topics to talk about.
I suppose I'd love to chat in regards to that .NET GPU compiler project out of GPU. I think it would be great to connect you with him. So.
Yeah, and I also work. I'm the alliance manager for Julia Computing, so I work with them or in touch with them pretty regularly.
Right on. Cool. Which one are you? I can't.
Oh, I'm sorry, Barton Fisk at NVIDIA.
Ah, got it. Cool.
Yeah.
Well, good. I'm glad we can broker some connections, even though we're not able to really get together. That's nice.
This is good. I saw this, and I wouldn't have been able to make it in person tonight, but since it's virtual, I was happy to drop in.
Very nice. All right.
So
well, nice to see many of you. let's try and do this again sooner rather than later. It sounds like a Kubernetes night is definitely in our future. I'll look forward to that.
I'll see what I can do.
Thank you all.